record on this.
Right.
Record. Stop recording. Recording. Yeah, recording. Okay.
And it's hanging off.
It is.
Yeah. Anyway.
Okay. Great. So we're on to chapter 5, which is isomorphisms and embeddings. Right. So, who's read through the chapter and who hasn't? Anyone?
I haven't.
I haven't.
Everyone's 3 months ago. Okay, great. Okay, so we're good on the very. So yes, so lambda expressions, as in many functional languages, the syntax is, so the slashes do work, backslash does work as lambda, but in usual people prefer to type lambda explicitly in Agda as a style convention, just because you can, so why not be fancy? The main difference is pattern matching lambdas, I think, in Agda that differs from other ones. Boot up an Emacs environment. So where am I? No. Yeah. Right. So yeah. So as with many languages, you can just use lambdas in place instead of having arguments on the left-hand side. You can write them anywhere where you can write normal expressions. The interesting bit is that you can case split on, you can pattern match on your arguments, and you do this by using curly brackets. Oh, doesn't allow you to do it there. So the auto mode, turns out auto mode doesn't work with case splitting on that. But for instance, you can case split from 0 to that one, and then it's separated by, the cases are separated by semicolons. So you can go. Arguments are, yes. And the parser is a little bit weird. So you need to bracket, even if you only have one argument, you need to bracket, which is a niggle. Should probably open a bug for that. Yes, so you're not.
You can have multiple arguments and pattern matching for the same lambda?
That's a very good question.
Otherwise, the parser is pretty wonky.
Let's try.
Because you can just have lambda mn arrow, right?
Yeah, let's see, 0, 0. Yes. So indeed, you can pattern match on. Yes. So indeed, that's the reason that you can pattern match on multiple arguments at the same time inside a lambda. Yeah. So the brackets are needed to disambiguate it from having 2 parameters, one called suc and one called n, which I guess makes sense. Maybe the parser could be a little bit clever and disambiguate, but maybe that would require type checking. Yes. So, anything else to say about pattern matching lambdas? Does anyone have any questions about them? Anybody think that you could do things with them or that you shouldn't be able to, or things that you should be able to but you couldn't after playing around with them? Okay, cool. Anybody got advice about using them? When do I use pattern matching lambdas? In general,
I tend not to use lambda.
They're quite rare. to actually use, I usually, if you have to pattern match on something, I usually define a helper function with a name. Because if you're pattern matching, it's complicated enough that it's useful to spit it out.
Something I never remember is whether a pattern matching lambda can be recursive.
Ooh. Why would you have a try and write that?
Well, because
how would you even?
Because let rec. So in the suck n case, I might have access to test n.
Yeah. Oh, right. Yes.
Is that allowed?
Yeah.
Yep. Huh. Okay. Cool.
I suspect because pattern matching just gets pattern matching on the left hand, the top level pattern matching gets compiled to these anyway. So
right. Okay.
Yes.
Yeah.
So yeah, that's a good point. Recursion is allowed.
They're probably also really good if you have a one constructor data type that's encapsulating something like a new type and you're just peeling it up.
Yeah.
Maybe.
Yes. Yeah.
I mean, pattern matching on sigma, right?
Yes, that is more common actually. Pattern matching. So pattern matching on pairs is often a good one. So if you have
I don't think we've seen products, but hey.
Okay.
Okay.
Okay, so here we go, products. So yeah, so
it's a thing.
It's a thing. Pairs are a thing. Again, it's defined natively in Agda. It's not a built-in thing. You can define it using the constructor for product is a simple semicolon. So
simple comma, I hope.
Sorry, comma, not semicolon. You're right. Comma.
And
what was the
one
question?
thing that you need to remember to do that I don't often, and Agda yells at me, that is that you need a space before the comma, which hurts me deeply.
Yeah, so that.
But, yeah.
That gets,
you need a space around every single thing which you don't want to be a discrete flexi.
I know why it is the way it is, but it still hurts my eyes.
Okay.
Yes, and again, that's an artifact of it being defined externally, externally
it's
rather than
because
internally.
it's just a usual definition of an operator.
And in fact, we can have a look at it.
Yes.
If we press Control Dot to follow a definition. So the product that we've written with the times is a non-dependent product. It's actually defined in terms of the dependent product.
Yes, which is why the definition is.
So the definition is a bit more complicated.
It is.
So you have, it's a dependent pair, takes in a type, and it takes in a second dependent type that depends on the first type. So the type of the second element can depend on what element you pass it into in the first pair, which allows you to couple values and proofs. For instance, you could have a pair X, or you have a pair of a number and the proof of its prime to represent a prime number. And yeah, the constructor, which is comma, and yeah, there's two projections, first and second. And yes, the direct product is just eventually, if you trace the definitions back, gets taken back to that is defined in terms of that dependent pair, but is a non-dependent one. But yes, as James says, that occasionally pattern matching lambdas are used if you want to operate over one or both of the sides of data. There are projection functions to it, but sometimes a pattern matching function that pattern matches on the pair is easier to write, or cleaner, more readable.
And if you make that test the swap function, then it's worth observing that you don't have to write the brackets here. Y comma X is well formed as an expression without brackets.
Yeah, so again, the brackets on the left-hand side are just to stop you from parsing it as 3 arguments.
Yeah.
Rather than. Okay. function composition. Okay, so function composition, yeah, you can define it in the usual way as in any functional languages. Function composition in the standard library is actually a bit more clever than this, because function composition in the standard library, which you import from function, is actually uses dependent function, composes dependent functions as well. So the type is actually, well, you can show it to scare people.
Yes.
It might be worth. Type checking. Yes, the type of dependent function composition is actually pretty horrible, but it comes with lots of uses. You do often want to compose dependent functions when programming in Agda. It's one of these functions that looks scary, but usually magically just works, and you never actually have to provide implicits, or you never actually have to worry about any of these arguments. It's one of the cases where all the implicit arguments do just work in Agda.
Yeah, it's easiest to think about it in terms of a non-dependent version and sort of hope it works in the dependent case too, and most of the time it does.
I've never come across a use case where it fails. So.
Well, sometimes it's a bit too tricky for Agda to figure out.
Okay.
No, I don't think I really ever encountered the real problem.
And then there's a non-dependent. So the convention in the Agda standard library is that the non-dependent versions of functions are primed, and that's a prime, not a semicolon. So you type it with a prime, not a tick. Sorry, I'm on a semicolon, obsessed with semicolons.
Yes. Backslash tick gives you the prime.
Yeah.
And as you can see down below, there was more than one prime too.
Yeah, and then non-dependent. No, I've lost it. Yeah, and then the non-dependent version is just.
What's the one with the subscript 2?
The subscript 2 is double composition. So if you're composing a function which takes 2 arguments, and you want to, you can, and the output, and you want to compose its output with another unary function.
Okay.
Yeah, so this is a useful file to look through data function. Oh, sorry, function. There's a lot of funky things you can do here, combinators of functions or whatever.
So in particular, the case of
case return or case of. Can you explain that to me, because I've never understood it.
Dangerous. Yeah. So so in many functional languages you have these case expressions, right? And they're built into the language. In Agda, they're purely defined. Can I explain case return of? Yes. So I have never used it, which is a good start. So yeah, again, it's as I understand it, it's telling you what. So if you're pattern matching on something dependent,
marking in an application where you want the thing to end up.
Yeah, it's providing, sometime when you're pattern matching on a dependent thing using case of, it can't infer the B. But it can't infer, it can infer what the final result is, right? B of X. So if you're pattern matching on X and you want something of type that depends on X, it can infer what B of X is, but it can't infer what the B is on its own, right?
Exactly.
Because it doesn't know.
And then because of the dependent nature, it thinks it's ill-timed because it only sees the result sometimes, right?
Yes.
Because it sees B of X and can't figure it out. The various branches of the pattern match.
Let's have a look at readme.case.
What does the keyword do?
Sorry?
What does the return keyword do?
So it's not a keyword.
It's part of the case return of operator that's defined.
Aha.
Yes.
And
So,
it specifies it's sort of, I guess it's sort of like the dependent pattern matching that's built into COP.
Yes.
And
which has the option to specify the return
yes,
family. Yeah,
yes,
okay.
and more, but yeah, anyway. Because the dependent pattern matching in POC is weird and tricky and more difficult than what's there in Agda. And yeah, so the idea is that return clause allows you to specify the type family into which you want to eliminate the X.
and yes, there's nothing special. I mean, this is just using the infix notation that we covered a couple of weeks ago. And yeah, there's nothing special about the return. It's just a name that we're binding as part of the function declaration.
So it's a mixed fix like if then else. Yeah.
Yeah. And I think the problem with the sort of simpler case of where you don't specify the B explicitly is that the type of F, if you use this, so the idea here, I take it, is that F will be a pattern matching lambda, right? And then this way you'll be able to use this as a usual pattern matching expression like in ML by using a pattern matching lambda in place of the F, which is supposed to do the right thing with an X, right? For each X, turn it into a B of X.
Yeah.
So we have an example here in the README files. Occasionally the README files in the standard library come through. So it shows a use case of it's a standard case where you're not doing a dependent pattern match. And then there's, yeah, and then the case return of, because you're returning a dependent function that depends on the case that you're matching on.
Can you explain the lambda that immediately is followed by a where? That's a bit funny.
Yes. So this is another form of, this is alternative syntax for pattern matching lambdas. So instead of writing the brackets round, I don't know if there's any actual technical difficulty in power between them, but instead of writing the brackets and the semicolon, you can write lambda where instead, and that triggers the pattern matching as well.
And it triggers the sort of block structure or
yeah, so it triggers the white space layout indentation.
So you can get the same layout as for ordinary function definitions.
Yeah.
Yeah.
Okay, so okay.
Yeah.
Can you use the brace and semicolon for ordinary function definitions?
For ordinary function definitions, okay, let's have a look at. So what would you like to type?
I'm just wondering if there's some way to because you can use the ordinary clause structure with pattern matching ones. I'm wondering if you can do the reverse, if you can use the semicolons and put things on a single line and things like that.
Oh, like this?
Except it would be, you'd have to use an arrow, I suppose. Yeah, I think you have to use the lambda then. So there's probably no way around it.
So
no, that's cool.
Oh.
So that does work because the semicolon literally, yeah,
it's separating the two lines.
It's a line separator.
So that's like a new line that's indented one space.
So what I would be curious about is whether you can use a not semicolon, a braces instead of the were for the module. But this is sort of,
that doesn't work.
That works.
So what would you like to type, Philip?
No, I think we're sort of veering sort of hard off track here. So
well, it's a little gentle bike shedding on a Friday morning.
Yeah.
Yeah, wouldn't we expect to have to use arrows if we were going to expect that to work at all?
Yeah, that's what I'm.
Oh yeah, okay, sure. We can try that. No. Yeah, no, it doesn't like that. If you're writing this,
if you write test 3 equals lambda that.
Yes, that would be absolutely fine.
So basically, the lesson I'm learning from this is that someone who is intimately familiar with Agda still asks questions about the syntax by just trying it.
Yes.
Yeah.
I mean,
so it's not actually possible to know the syntax. You just have to experiment.
I mean, I think a lot of the syntax around lambda expressions is sort of entirely optional or almost entirely optional. I'm not sure I ever used it, and I wrote a bit of lambda code.
I have never used lambda where. I
don't think I've ever used a pattern matching lambda at all.
Yeah.
I have used lambda where in papers, and reviewers always say WTF, basically. The one use case where I could imagine it were useful might be if you could have auxiliary function definitions, so local lets, inside the body of a where defining a lambda. But if that's the way you write programs, then maybe you need help of a different kind.
Yeah, I would agree with James. I think that's probably possible in that.
Because it's where syntax.
It's where syntax, you should be able to define.
So you ought to be able to open a module, write patterns, make local definitions.
Don't do this. You probably can, but don't do it. Yeah, stick to
human 3.0 might be able to, but not us.
My advice is stick to the bracket. If you want to use a pattern matching lambda, stick to the curly braces, because that's what that's what anyone reading your code will understand.
Yeah.
Okay.
Anyway.
In the interest of trying to achieve the end of chapter 5, we can move on to extensionality. So extensionality has a huge history behind it, and there's various developments which I'm totally inadequately equipped to speak about. I'm sure what I will say is that Agda does not, you cannot prove extensionality in Agda's basic type system. Therefore, and for those who perhaps aren't familiar, extensionality says that basically if two functions are equal on every input, then the functions themselves must be equal.
So we defined equality, if you recall, last time we met, and it does not, like of that definition, extensionality does not hold in general, right? And yeah, so basically what we can do and what the authors do in this book is to state that we'll assume this is a fact, right? We'll state it as an axiom.
Yes, so postulate introduces a new statement that you don't have to prove, that you can use, but if you try and normalize out, or it's non-computational obviously because it has no definition. If you try and normalize out anything that uses extensionality, it's not going to work. But it does allow you to assume it in your programs.
What will happen if you try to normalize?
Let's try it out.
Okay, so what's a postulate? It's just an assumption in the context of the system. So you will have enriched the class of normal forms, and in particular weakhead normal forms, with extensionality applied to a bunch of stuff. And once you have extensionality in head position, it can't reduce. It's simply a name.
Yeah.
So you're stuck.
So it does an error. I'm trying to normalize. So I put n in the bracket, in the hole. I'm pressing Control-C, Control-N to normalize, and in the buffer, it just comes out as n. You can't inspect it.
I mean, it says it reached the position where it doesn't know what to do.
Yeah, yeah, no,
Yeah.
it's very sensible behavior.
And why
It's as normal as you would get it, like.
Yeah.
right? But why is that a problem? It's because we've said that proofs of f equals g should be of the form REFL something.
Yes. And
But we're never going to get that if we have extensionality, because it's just going to be an unanalyzable neutral term that can't reduce to a REFL.
Yes.
So we adding postulates may be safe logically, may be consistent, but violates a kind of canonical forms lemma that says if I have a term and it inhabits a particular type, then its normal form should begin with a constructor for that type. And that obviously changes once we move to
well, as we've seen here, right?
Yeah, as we've seen here with mere n. Postulates have changed the language of normal forms to include neutral terms that are stuck. They can't do anything.
Postulates are obviously, I mean, in this case, extensionality is kind of a, you can argue that it's a sensible postulate to add. Postulates obviously have no such restrictions. So you can do things like you can postulate 1 is equal to 2, and Agda is going to accept that. So postulates introducing postulates is dangerous, because if what you postulate isn't consistent with Agda's internal system, then you're going to be able to prove false, and all your ability of your proofs are wrong. For that reason, Agda has a safe flag that you can pass it that will error if you want to be absolutely sure that your proofs that you have, that everything that you've written is true, and that you haven't accidentally introduced postulates, or you're type checking someone else's code and you don't want to check that they haven't introduced postulates somewhere sneaky. You can pass in a safe flag when you hit compile, and Agda will error at anything that could possibly violate its assumptions. So postulates or dangerous pragmas that you've enabled, dangerous options that you've enabled, like cumulativity. And
does it also allow you to check the genuine? Like you can see like which postulates a certain number depends on.
Which postulates a certain number depends on? No, so you can see the module structure, but you can't have a proof graph of the individual.
It seems like what you would want is the ability to just to say, I'm happy with these postulates, but anything else, give me an error.
Yes. So that ability does not exist. So the reason why I bring this up is because actually postulating extensionality is, in my opinion, the wrong way to go about introducing the extensionality to your code.
Mm-hmm.
The way to do this, the way to get extensionality and still maintain the safety of your code so that it will check under the safe flag, is to introduce it as an module argument, as an assumption. So assume it as a precondition to your function. So the Agda standard library has files called has a subsection called axioms, which are rules. Ooh, this is why I don't know the standard library, which I've written and I'm in charge of. Source axiom. Oh, it's okay. There's different types of extensionality. Okay. Propositional. Right. And here we formulate extensionality as a type. So you have to provide it certain levels, but you can say at what level you want extensionality to hold. But basically it gives you extensionality. So the safe way of doing this without introducing postulates is to assume it. Let's put a level. We haven't covered levels. Ignore this thing. It's not super. Ooh. Why is that in there?
Oh man! Sorry.
This is very reassuring, by the way, that you're having this trouble. Because
deprecated.
helps me not worry as much.
Yes. Yeah. Okay. So the idea is that you postulate extensionality you take it in as a argument to your proof, and then you can prove. Then you have your type. So
basically, you assume extensionality locally for things that require extensionality, rather than assuming it globally and being able to have it sort of wherever, right?
Yeah, I'm not sure. Have a type. So you have a proof on the right-hand side. You assume that you can use it locally. You'll never be able to instantiate this function. You'll never actually be able to call this function without either assuming extensionality again in the function that's calling it or by postulating it. Which
is sort of fair game, since if you postulate that won't compute till the end anyway, right?
So Matthew, the way to come good on this promise is now to put that assumption in the module signature.
Yeah, so exactly.
The module you're defining.
So I was wondering. So another thing we definitely haven't covered is that you can parameterize modules by values as well. So let's have a look at. So you can have your module, you can have dependent modules, and that allows you to introduce a parameter that is used everywhere within the module. So everything depends on that parameter. Let's have a look at algebra definitions. So these are some definitions of basic algebraic operations, which I think we covered in the first thing. So things like associativity, commutativity. And what you notice is that they here, as they're written, they have taken a binary operator as an argument. And they use a binary operator, but they also use this equality, right? Which is the equality that you're assuming. And the equality is passed in as a parameter to this module. So,
this is the carrier.
Yes. So you pass as and it's also passed in, the carrier set of what's underneath, and then the equality with it. And what this means is that this can either be passed or not passed when you open the module, as we shall see in a second. But this equals sign becomes available everywhere in this file. So we'll come back to we'll just come back to the implications of passing module parameter, but just to finish the extensionality question, the really good way of doing this to avoid you having to pass extensionality everywhere through all your proofs is that if a module uses extensionality, you can postulate it as introduce it as a module parameter up here, and then all your proofs in this file will have access to it.
But if you do that,
can you run any code that uses?
Sorry, Joe?
Sorry. I was just asking if you can you run any code that uses a postulate?
Can you run it?
Yeah.
You can sort of try, but if it actually uses the postulate, then it will not necessarily reduce the constructor.
Yes. It depends. So you can mark, it depends whether it's possible that you might, if you only use a postulate in places where it's runtime irrelevant,
okay,
then you might be able to get away with introducing postulate and still having your code compute and your code compile. I haven't tested that myself. To take that with
you mentioned that the extensionality postulate was consistent with the underlying type theory. Is there, or what is the kind of mechanism by which a user would want, if they wanted to check that a postulate that they wanted to introduce was consistent with the underlying type theory, where is that done? Is that in the realm of
PhD thesis?
Yeah, 5 years of study.
Okay.
I'm working super hard by building a model.
Very good.
Yeah.
Sorry.
No, that's okay. I have no desire to introduce new postulates into Agda yet, anyway.
So on this note,
relevant here is that Martin Hoffman's PhD thesis, part of it was to show the consistency of extensionality with respect to other models, the existing models of type theory. but also to show that it wasn't derivable by constructing models in which it was false. So there are two sides to this story.
So for extensionality, a lot of the sort of more standard models would probably have it, right? But yeah.
So if you're really keen on extensionality, there is a flavor of Agda called cubical Agda, which I'm not going to talk about, but which uses a cubical model of type theory, which does have, except in which you can prove extensionality in Agda. And there is an alternative standard library out there for, it is relatively well supported. There's an alternative standard library for cubical Agda out there. It's, I mean, if Agda, yes, it's harder to get your head around. It's not as, the cubical interaction model is not as polished as the interaction model in mainstream Agda. So it's, you need to know a little bit more of the gory details about how cubical type theory actually works to actually use it, but it is out there.
But in general, there isn't a straightforward way of knowing whether or not your postulate is sane or not, unless it's one of these ones that someone's done a PhD on.
So with any sorts of axioms like that, particularly when you start adding more than one, it can go horribly wrong, horribly bad.
Of course.
I had just one question about module parameters.
Yeah,
because it slightly does my head in. Well, in the already in this one that you already have, actually, where you postulated at the top, is extensionality is not in scope at that point. So you actually have to have done all the imports before you can even declare the module. You need the levels as well, I guess.
So yes. So imports don't actually have to go inside the module, top level module, to support module parameters. Indeed, for exactly the reason that you need to support module parameters. So imports can come outside of them. In general, the convention is that you only put the imports on which your module parameters depend outside.
That's a sensible convention.
And any modules that you're importing that do not, your module parameters do not depend on, you put inside.
Can I ask a question about what goes in the files? So you can put stuff in each of these files that goes in the top level module by just putting it outside of the module keyword?
So you can't put definitions, no. But what you're asking?
But those open imports are opening in the scope of the top level module, is that right?
Yes, yes.
But
you can't, what you can't do is that you can't open them publicly, I really hope. Okay. So it says the public keyword is ignored here.
So each file can extend the top level module, but just for itself by doing these imports.
Oh, you mean if it's, what do you mean by the top level module?
There seems to be a funny notion of a top level module. I originally thought that the top level module would be a file at the top level of the directory hierarchy, but it turns out
no such file exists. So I don't think that concept really exists in Agda.
Okay.
But these open imports, they're only being opened for stuff that's in this file, not for
How is that reflected in the type theory, the concept of the file?
So the concept of a file is not really in the type theory. Inside the compiler, right? It brings everything into it. So, okay. So, but inside the compiler, right, it will bring everything, it will qualify everything that you import by the required module parameters. And then everything is treated, or I mean, eventually everything is treated as it's in this one. Everything you import becomes fully qualified, and then it's treated. And at that point, once you've fully qualified everything, then the concept of a file disappears.
Okay, so I'm going to have to figure out what the rules for that are.
So one of the things that I was going to mention is that, so algebra.definitions takes in an inequality, right? Maybe this will answer your question, but you don't actually have to provide it. Okay, so if you don't provide it and you want a proof of commutative, right? Commutative. Right? It will automatically append anything. If you don't provide it, it will automatically append anything that was provided as module parameters to the type signature of the definition itself. So these, if you don't provide them, then the type signature of commutative, that's what its type is, becomes this thing, right? So it takes in, you have to pass, because you haven't passed it at the module level, you have to pass in the carrier set and the equality explicitly, and then the operation as well. Whereas if you opened it with, so we can provide propositional equality. The problem with this, right, is that propositional equality is generic. So it's not going to know what the carrier set is. So we're gonna have to pass that in explicitly. And at that point, the type of commutative becomes what you find in the file.
Mm-hmm.
So basically, depending on how you want to use the algebra definitions, whether you want to use them for different equalities and different carrier sets in your current context, or whether you have one particular carrier set and equality, you can either import it like here or as before, right? And here it only sort of, you can think of it as only importing one particular instance of definitions for this particular equality and carrier set.
And you can partially apply it in the same way that you can partially apply functions. You can partially apply module parameters as well. So for instance, you can just pass in the carrier type, and then
things will probably get horribly wrong, right?
Ooh.
The level comes before the carrier type. The level of equality comes before the carrier type, and it can probably not figure it out.
Yeah, it should do,
because the n is at level 0.
That's kind of scary.
No, but the level of the relation is separate, and it does not. There's two levels.
Yeah, there are two levels. Boom.
Oh,
and
yes.
That's not the right level.
Yes.
B.
Yeah.
B.
Yeah.
No, it's A.
Oh, no, it's L, I think.
Okay, so yes. So what was the problem here? We were trying to omit we were trying to omit the equality. So we weren't passing in the equality. We were passing in the type of A. So Agda could infer from the type of capital A what its level was, but it could not infer the level of the equality because we weren't passing in anything that had. So that was why we were getting the dreaded yellow.
Yeah.
So implicit arguments. And indeed, it actually told us what the problem was if we'd read it. And it said that it couldn't infer what L was. It knew, interestingly, it knew that it should be level 0.
But it's sort of.
But
wait, why does?
Well, because we've used it.
Because this equality
we've used
here is equality on math process at level 0. Yes.
But it wasn't competent in actually unifying them.
Yeah.
I'm very reassured by the difficulty you're having in explaining these things.
Yes.
I think part of it is we're sort of looking at the standard library and things that in the standard library are defined in, full generality, and that means that there's all sorts of stuff
This is a bit weird. It's very rare that you instantiate the module parameters and you only provide
some
implicits to implicits explicitly.
Yeah.
Usually you either provide no explicits or you provide the explicits, and that's enough for Agda to infer the implicits. So the reason why we're getting these questions where we're a bit unsure about it because we're writing very weird Agda to explore the edge cases.
Anyway,
but,
should we look a little bit more?
Yes. So, extensionality. Yes, so they're defining an alternative version of addition, which is pattern matching on the right argument instead of the left argument, as we discussed. They then have a proof of congruence. So that, you know, if anytime you add n plus n, it's the same thing as adding it with this alternative operator. But this is a proof that they're equal on all arguments, right? This is not a proof that the functions themselves are equal. And to do that, you would need extensionality. And we need to apply extensionality twice because extensionality by default only, the functions only take a single argument. So first you need to prove that plus something plus n is equal to something plus n, and then you need to prove, and then you use extensionality again to prove that n plus the pluses, the raw pluses are equal. Yes. And then there's the obvious extension-dependent extensionality, which is simply a matter of altering the types of the FFG functions, the actual format of the axiom stays the same. Isomorphisms. So again, there's nothing special about isomorphisms in Agda. You build them up, you define them, and build them up for Agda.
So isn't this the first time we're really seeing records?
Is it?
Or have we seen them before?
Can anyone shout out? Does anyone remember who's new to Agda?
It says at the bottom of the screen, the above is our first use of records.
Oh, great. Yes, that would solve it. Yeah. Records. Okay. I'm happy to describe their practical uses. Would anyone like to describe it from a theoretical point of view first, or it's
so there's a definition, alternative definition below that defines a data type, right? And so we can think of records as one constructor data type, sort of like records in normal functional programming languages or even non-functional programming languages, right? So basically, there's what we want to specify is named fields as opposed to arguments to constructors, which are generally unnamed or at least not in the same way. And what we get from that, from the record syntax, is we're getting projections for free. So the field names become projection functions. 2 becomes a defined constant, from becomes a defined constant. And what they do is they take a record argument and produce whatever they should produce, right? Whatever it says in the field description. So they basically behave like ML or Haskell records would behave, with the exception, obvious exception, that they can be dependent. And we see the dependency here because from composed with 2 and 2 composed with from depend on from and 2. Right, use from and 2 in the times. Yeah.
It's interesting that in this particular case, from 2 and 2 from could be implemented as virtual fields, which would be calculated on use. because they basically just compose the first two fields. You don't actually have to store them.
No, they don't.
No, these are witnesses to propositions about the first two fields.
So what from two, so this is supposed to encode isomorphism, right? Isomorphism understood as a pair of functions between the two sets, and a proof that they compose to identity.
Okay.
Right, so this is in some way saying from composed with two is identity, and two composed with from is identity. It's written in a sort of long form in order to not force us to use extensionality, right? So it's actually parameterized rather than saying from composed with two is equivalent to id, which we could also say, right? But yeah, it's
yeah. So you actually have to give the functions from and to, right? Because that is part of the proof that the arguments to this this isomorphism constructor are actually isomorphic.
Yeah. So those that from circle to and to circle from, those are just names. They could be anything, right?
Yes.
They are record field labels.
Yeah.
So this is the sort of common Agda practice of sort of squishing things together and treating them as names, right? So from composed with two, you could name from composed with two without any spaces. And this is sort of what's done here, not quite, because it's not actually from composed with two, it's a proof that for any x, from composed with two is identity. Well, sorry, it's a proof that from composed with two is identity.
Yeah, it's slightly confusing that, but there you go.
Yeah,
Is there a convention to indicate that something is a proof of something rather than just directly that?
So the convention that the standard library takes is that the dashes in names usually indicate, so that in the standard library this would be called from dash to. Anything with dashes in the names are proofs about the functions that are used, that are named in the name that uses the dashes.
Wow, I didn't know that.
Except for, is this example not from the standard library?
No,
that's from PLFA.
This is from PLFA.
So
they have their own conventions, but often line up with the standard library, but not always.
I don't think there is an isomorphism in the standard library.
There is. I mean, this is called an invert. This is called inverse, yes. But it's not called isomorphism.
Also, so the notion of isomorphism is a bit contentious, and this notion is, I mean, it's okay, but it's very built-in or very propositional equality specific.
Yes. But yes, that's an excellent question. It's also their location for the most part. Most modules will either be specialized in proofs or in definitions. Usually a module will either define types and functions that compute, that are classically one would view as computing, or there's modules that have proofs about those functions and definitions. So another way of distinguishing whether it's a proof or a function is simply its location in the standard library as well.
There are conventions for naming modules that contain proofs.
What about?
Is there a convention for naming which modules contain proofs?
Yeah, so for data types, they're usually called, for concrete data types, it's usually called property files, so dot properties. So it's, for example, data.nat.properties, data.integer.properties, data.list.properties, and then data.list.base, data.nat.base will contain the types and the functions, and then data.nat re-exports the whole of the base module, so all the types and the definitions, and some of the proofs, which we're very inconsistent about, and is part of the things that we want to fix as version 2.
Sadly, we have a prior lunch engagement, so this is a moment to stop. Thanks for the questions.
So thanks for today, and we'll meet in 2 weeks' time at the same spot. So
sounds great.
And hopefully we'll go a little bit ahead. So I think we'll chat a bit and figure out whether there's some reading to be done for next week or whatever, and figure out for 2 weeks' time, and then figure out how to go forward.
Thanks much.
Thanks.
Bye.
Thanks very much. Bye.
Bye. Thank you. Bye-bye.
Enjoy your newfound command of Control-C, Control-L.